We've all seen the trend. Billionaires and influencers seem to be dying to leave Earth behind, using their wealth and power to punch a first-class ticket off this planet before things get too uncomfortable. That technological optimism crashes hard against biological reality. The universe outside our atmosphere is violently aggressive, completely devoid of breathable air, and perfectly calibrated to destroy human life. To see exactly what we're up against, let's take a one-way trip outward from the sun, tracking exactly how quickly, and bizarrely, each celestial body would dismantle the human body. Earth is a microscopic oasis. Stepping outside its borders means contending with physical mechanics far more hostile than any luxury travel itinerary suggests. Starting closest to the sun, Mercury offers an immediate, brutal thermal shock. With virtually no atmosphere to distribute heat, you face a rapid choice: cook alive at 800 degrees Fahrenheit on the day side, or freeze solid at -290 degrees in the dark. Moving outward to Venus, the threats multiply. Venus is 95% the size of Earth, but it replaces our breathable air with dense clouds of highly toxic sulfuric acid that would dissolve your spaceship, your spacesuit, and eventually your skin. Yet the acid wouldn't even have time to finish the job. The true killer on Venus is its barometric pressure, which sits at a staggering 92 times greater than what we experience at sea level. That immense atmospheric weight equals over 1,300 pounds resting on a single square inch of your body. It would crumple a spacesuit and the human trapped inside it in a matter of milliseconds. Proximity to the sun drives violent atmospheric forces and crushing pressures that render the inner planets impenetrable for human biology. This brings us to the primary targets for cosmic colonization: the Moon and Mars. Free from the crushing pressure and intense heat of Venus, their relatively calm surfaces look deceptively appealing. Look closely at this photograph of the lunar surface. The fine gray dust coating the ground is called regolith, and it serves as the Moon's pervasive hidden killer. Billions of years of high-speed micrometeorite strikes have churned this rock into a jagged, abrasive powder. It clings to everything, grinds spacesuit joints to a halt, and if inhaled, slices human tissue, causing an agonizing condition similar to black lung. This image highlights the desolate, rocky Martian horizon, anchoring the barren reality of our next stop. Mars has a surface pressure roughly 6% of Earth's, making its atmosphere over 100 times thinner than our own. Compounding that thin air, the atmosphere is 95% carbon dioxide. As CO2 rapidly builds in your blood, you experience the stressful, violent sensation of breathlessness. You pass out in a state of sheer panic, gasping for oxygen that simply isn't there. The most survivable targets in our local neighborhood merely offer a choice between coughing up glass or suffocating in a state of sheer terror. Traveling further outward, we reach the gas giants. Here, the concept of solid ground ceases to exist altogether, replaced by thousands of miles of descending, toxic gas layers. This image captures Jupiter's swirling cloud bands and the Great Red Spot. The violent atmospheric dynamics create thunderstorms wider than Earth itself. When a descending ship inevitably gets caught in these powerful updrafts, massive lightning strikes would incinerate everyone inside in milliseconds. This technical image reveals the concentric bands of Saturn's rings. To even attempt to reach the planet's core, a ship must navigate a 175,000-mile-wide debris field composed of billions of high-speed chunks of ice and rock, creating an impenetrable obstacle course. Should a ship somehow slip through the rings intact, the secondary killers wait below, upper winds blowing at 1,600 feet per second, followed by a core burning at 15,000 degrees Fahrenheit. Interacting with the gas giants guarantees rapid destruction, whether you are ripped apart by high-speed space debris or erased by electrical incineration. Out at the ice giants, the immense distance from the sun means planetary physics begins to behave in completely alien, mind-bending ways. Look at this photo of Neptune. The Great Dark Spot visualizes the most extreme winds in the entire solar system. These supersonic, turbulent vortices are driven internally by the planet's core energy, tearing across the atmosphere at 1,200 miles per hour. Getting sucked into a Neptunian vortex forces a spacecraft into a violent spin. The immense centrifugal force causes the blood to pool in your legs, rapidly starving your brain of oxygen for a gruesome, excruciating end. Moving to Uranus introduces an even stranger hazard waiting deep beneath the clouds. Down near the rocky core, extreme temperatures clash with crushing atmospheric pressures to create bizarre quantum states. This super-pressurized environment forces elements into a compressed, exotic soup. The atomic weirdness at these depths would violently collapse the carbon inside you and literally crystallize your body into a human diamond. The ice giants replace standard hazards with physics that completely rewrite your physical reality, violently compressing your atomic structure into something entirely non-human. This image captures the harsh contrast of Pluto's jagged terrain against its plains. Out at the edge of the solar system, surface temperatures plummet to -387 degrees Fahrenheit. Those mountains are actually formed from rock-hard frozen methane, guaranteeing any attempted landing ends in a catastrophic crash. The unique threat here comes from gravity. Pluto and its largest moon, Charon, are tidally locked, constantly showing the exact same face to each other. This generates intense tidal forces capable of grabbing a descending ship and violently smashing it down onto that jagged ice. Our final destination requires traveling an agonizing 132 astronomical units from the Sun to reach a dwarf planet nicknamed Far, Far Out. At this distance, the biological hazards of the voyage take over. Decades of long-term exposure to microgravity atrophies muscles and rapidly deteriorates the skeleton, meaning astronauts would likely succumb to their own bodies failing long before they ever arrived at their destination. Leaving the solar system entirely proves that the ultimate cosmic killer isn't a planet at all. It is the sheer, unsurvivable vastness of the deep void. The journey through this cosmic gauntlet reveals a stark reality. Space acts as a high-speed engine for the rapid deterioration of the human body. The fantasy of rocketing away from a warming Earth is a biologically flawed survival strategy. It completely ignores our profound physical vulnerability the second we leave the atmosphere. Human biology was custom-built over millions of years of evolution to survive in the specific, highly fragile biosphere of exactly one planet. It is infinitely easier, cheaper, and more practical to fix the problems we have right here on Earth than to attempt to survive anywhere else in the cosmos.